Hello, this is the Group 1 and the course of Mtec 102, or semifinals in Week 1. Topic is about the manual radar plotting, and I am joined with Cadet Ancho Abraham and Cadet Anka Jefford, and I am Cadet Alves Christian. Course outcome: manual plotting techniques given the information from the radar observations. Learning outcome: at the end of the session, the students shall be able to comprehend the history of maritime and navigation radar, determine why radar is such a valuable tool, recognize the ship parameters. Importance of the topic: the students can perform manual plotting techniques given the information from the radar observations. History: new technologies of radar become available to merchant shipping with the end of hostilities in 1945. Radar on merchant ships was initially installed for commercial purposes, on ferries to maintain better schedules in fog, and large shipping vessels. Radar was treated with great suspicion by the mariners. With improving technology, after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction of sea number of serious collisions at sea. Internal Conference of Safety of Life at Sea, or SOLAS, in 1960, revised the international regulations for preventing collisions at sea by adding rules to take account of the use of radar and recommendations of the use of radar information as an aid to avoiding collisions at sea. The International Conference of Safety of Life at Sea in SOLAS 1974 adopted provisions to the SOLAS Convention, making radar a mandatory carriage requirement for merchant ships in a phased program starting 1980, which finally completed in 2002. SOLAS requirements: all merchant ships of 300 gross tonnage and over now shall carry a radar, and many carry two. IMO adopted performance standards for marine radars, which are used in integration with other navigational equipment required to carry on board ships, such as an automated target tracking aid, ARPA, AIS, ECDIS, GNSS, and others. Non-SOLAS ships: many small craft with 2 millions also carry radar voluntarily, as manufacturers have produced cost-effective designs for their needs. The shipmaster's point of view: the key facts are that radar remains and will remain the primary system for collision avoidance, and radar is very important tool for navigation. Why is radar such a valuable tool? Well, the master and the watchkeepers have confidence in information radar provides because its operation is ship-based, not reliant on third-party sources. It has a proven track record. Radar is useful with SARTs when engaged in search and rescue. In short, in its display, radar offers the watchkeepers the basic reality of all targets relative to the ship. It therefore aids the watchkeepers and helps in decision making for both navigation and collision avoidance. Early action is required to avoid a close quarter situations. Therefore, early identification of closing targets is essential. Watchkeeping officers need to be competent in the use of radar and trained in its use in the application of ARP.
I'm Cadet Angkas. I'm gonna continue the report. Ship parameters: speed up to 25 knots, length largest container ship 335 meters, capsize bulker 300 meters, Panamax 220 up to 230 meters, emergency stopping distance 3.3 kilometers up to 5 kilometers or 1.8 nautical mile up to 2.7 nautical mile. Emergency turning radius 550 meters up to 840 meters or 0.3 nautical mile up to 0.45 nautical mile. Displacement weights 100,000 up to 250,000 tons. Practical requirement: to start plotting targets and determine their course and speed when the target is between 8 and 10 nautical miles off. Navigation: radar gives accurate information on the distance from charted futures and assists in maintaining the ship course. Radar will normally show a metry of high land mass at a range of 20 miles. This is considered by seafarers as a minimum requirements. And the next slide is the images of navigational radar. Discrimination of targets from a watchkeeper's perspective: to be able to distinguish a tug from its tow at sea at 12 miles range, approaching a rig on a supply vessel, to clearly identify the standby boat from a rig at 6 miles range, to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range. Navigation: radar greatly assists navigation during poor visibilities. Pilots rely on radar at close range and reduce visibility at pass buoys and beacons. Resolution MSC 192/79. Range: the radar system should be capable of displaying 2-point targets on the same bearing, separated by 40 meters in range as two distinct objects. Bearing: the radar system should be capable of displaying 2-point targets of the same range, separated by 2.5 degrees in bearing as two distinct objects. Resolution MSC 192/79. Minimum range: with own ship at zero speed, an antenna height of 15 meters above the sea level, and calm condition, the navigational buoy in Table 2 should be detected at a minimum horizontal range of 40 meters from the antenna position and up to a range of 1 nautical mile without changing the setting of control function other than the range scale selector.
Good, good day, sir. I'm Cadet Ancho and I'll be the one to continue the report of Cadet Ankas. Antine. So the pitch is 3 degrees and the roll is 25 degrees. Yaw, 5 degrees. So vertical beam width is 20 to 30 degrees. So this is the X-ray band radar, and the lowermost part is Sierra band radar. So this is the probability detection of WP8B report November 3. So this is the picture. As you can see, this is the radar and the target. This is the radar. Okay. These are the equipments needed on the bridge. So this is our references. That's all of our report. Thank you.